See here, in today's session, I want to talk about how can we modify the element. Okay, an element, modifying an element in linear single linked list, modifying an element in linear single linked list. How can we modify the element in the linear single linked list? See here, for example, here one linear single linked list is there. These are the elements. In the previous session, already we created it. So this is the linear linked list. So this is the first node. This one is the last node. Total how many elements are there? 5 elements are there. 10, 20, 30, 40, 50. 5 elements are there. 5 nodes are there. Okay. So this is position 1. This is position 2. This is position 3. This is position 4. And this is position 5. Okay. So now what is our task? We want to modify the element at given position. So we have to give one position value. I want to define the method. That method name I'm giving as modify. So what is the method name? Modify. We give the position value. So which position value we want to modify. And the second argument is value, with which value we want to modify. So we are giving one position and value, two values. So I'm taking two arguments here. To capture the position value, I'm taking int p. To capture the value, to capture the new value, I'm using int v here. So I'm taking two arguments, p and v. So p captures position value, v captures the new value. I don't want to return any value. So return type is what? White. Now here only two cases are there. Whether we want to modify first element, modifying first element. This is one case. Okay. So modifying other than first element. Modifying other than first element. Modifying other than first element. That's it. So how can we modify the element in the linked list? Now see, observe here. So if position value is 1, if p value is 1, so we are calling like this. L1 dot modify, L1 dot modify. I'm giving position value as 1. So first element value is 10. I want to modify this 10 value with 100. I want to modify this 10 value. This is the 10 value. I want to modify this 10 value with the new value 100 with 100. I have to modify 10 value with 100. So for that, we are giving position value as 1 here. Position value as 1. And the new value I'm giving as 100. So what is the new value? 100. So position value is 1. New value is what? 100. So position 1 value, I want to modify with the 100. So for that, I'm giving position value as 1. So if position value is 1, which code we have to write? Observe now. Observe. So if position value is 1, see here. So this one, we want to modify this one now. Oh, just a minute. We want to modify this one. This 100. This 10 value, we want to modify with 100. This 10 value, we want to modify with 100. This value, we want to modify with 100. So here I want to get the value 100. So for that, which code we have to write? Observe here. So this first node's name is what? First. First node's name is what? First. So this one is the first X. This one is what? Next. So if you want to access this value, if you want to access this 10 value, what we write? First X. What we write? First X. So now first X value I want to modify. So make first X value as 100. So this 100 is we are capturing in V variable. This 100 value we are capturing in the V variable. So what we have to write? First X equals to V. So what is the V value now? V value is 100. So this first X value will be modified with 100. So this 10 value will be replaced with 100. That's it. Observe here. I'm writing the code. So if position value is 1, just simply modify the first element's value. So to modify first element value, what we write? First X equals to B. This is the code. First X equals to B. So we are modifying the first element value. Next. Else, otherwise, Otherwise, what we have to do? Observe. So take a pointer variable here, node pointer, take a pointer variable. So assume first one as the pointer. Assume first one as the pointer. So we have to go up to the position now. So in the whenever we are deleting or inserting, we were going from we are going up to position minus one. Whenever we are inserting or removing, we were going up to position minus one. Now we have to go up to the position. Okay. So for example, I am giving position value as 3. So we are calling like this. We are calling like L1 dot modify. I am giving position value as 3. I'm giving position value as 3. I'm giving new value as 100. So at third position, so here this value, third position's value is 30. I want to modify this value with 100. I want to modify this value with 100. Okay. Or otherwise, I'm giving position value as 4 for clear understanding purpose. What I'm doing is I'm giving position value as 4. I'm giving position value as 4. So assume this first node as the this. So now what is the position value? Position value is 4. So position value is 4 means that this element we want to modify with the new value 100. With the new value 100. So this fourth position's value we want to modify as 100. So we have to come up to this position from the first. So assume first node as the pointer. So assume first node as the pointer. Assume this first node as the pointer. So now if this is pointer next. So next time make this pointer next as a pointer. Okay, next time make this pointer next as the pointer. Next time make this pointer next as the pointer. Now this is the pointer. We are coming up to that position. So position value 4 we are giving means we are coming up to the position 4 only. Whenever we are inserting or removing, we came up to position minus 1. But now we are coming up to the position. Okay. So now we are coming up to the position. So which code we have to write? Observe. Observe carefully here. So now this one is the pointer. So assume first node as the pointer. So for that, what we are writing? Pointer equals to first. Pointer equals to first we write. So next pointer next we have to make as the pointer. So pointer next make as the pointer. So for that we are writing pointer equals to pointer next. So this code we have to execute for how many times? Observe here. How many times we have to execute? So first time this pointer next is becoming pointer. Second time this pointer next is becoming pointer. Third time this pointer next is becoming pointer. So 3 times we have to make pointer next as a pointer. So now we are giving position value as 4. So when position value is 4, so 3 times it has to execute. 3 times this statement we have to execute. Okay. So means position minus 1 times we have to execute. So write this statement in the loop for int k equals to 0, k less than or equals to p minus 1, k plus plus. Okay. So now this is a pointer. Now we have to modify. So for modifying, which code we have to write? Observe here. Just a minute. I'm writing clearly. Oh, so this is the code we want, and this is the code pointer. So we are assuming first node as the pointer. So next time pointer next is becoming the pointer, pointer next is becoming the pointer, pointer next is becoming the pointer. So how many times we are doing? P minus 1 times. If position value is 4, 3 times we have to do this process. If position value is 5, 4 times we have to do this process. So now this is the pointer. This is the pointer. This one is the pointer. So I want to access this value. I want to modify this 40 value. So to modify the 40 value, so here this one is the X. This one is what? This one is the next. This one is the next. So this pointer X value, I want to modify with the new value 100. This pointer X value, this value, this value. I want to make this value as 100. I want to make this value as 100. Okay, so if this name is pointer, if this node's name is pointer, to access this location, what we write pointer x. So right here, pointer x equals to 100. Pointer x equals to 100. This is the code. So 100 value we are capturing in the variable v. Yes, in the variable v. So now v value is 100. So now instead of writing 100, here write v. That's it. This is the code for modifying an element at given position. Okay, so we are assuming first element as the pointer. Next this pointer next becomes a pointer. Next this pointer next becomes a pointer. Next this pointer next becomes a pointer. So we are doing this process for 3 times because position value is 4. So now this one is the pointer. I want to modify this pointer x value. Now pointer x value is 40. To modify pointer x value as 100, write pointer x value as 100. 100 values in the v variable. So write pointer x equals to v. That's it. This is the code. This is the code for modifying. Very simple. Okay. So I'm writing the code here. So we're assuming pointer as the first. So next pointer next should become the pointer. So pointer equals to pointer next. So we have to execute this code for how many times? For p minus 1 times. So right, for k equals to 1, k less than or equals to p minus 1, k plus plus. So position minus 1 times that execute this code. So now for modifying, just simply write pointer x equals to new value. New value is in the v variable. Hence we can modify the element. So here only 2 cases are there. Here only 2 cases are there. Okay, either we are inserting at position 1 or we are inserting other than position 1. If we are inserting in the position 1, just simply make first x value as v. If we are inserting, if we are modifying at position 1, just simply modify first x value with the new value v. Otherwise, if the position is not 1, so go up to the position. So go up to the position. So for that, we are assuming first node as the pointer. So next pointer next will become the pointer. We are doing this process for position minus 1 times. So now modify the value. So to modify the value, so now that current node name is pointer. So pointer x equals to v. So now value will be modified here. So in this example, position value is 4. So we are assuming this first node as a pointer. Next to this pointer next is becoming pointer. This pointer next is becoming pointer. This pointer next is becoming pointer. This code is executed for p minus 1 times. Means 3 times. 3 times this code executed. Now this is the pointer. So pointer x value is v. V value is 100. So pointer x equals to v means this x value will become, this pointer x value will become 100 now. So hence we can modify the node value. Okay. So I'm copying this code. So this is the code for modifying an element at given position. I'm copying this code and I'm pasting here. In our previous program, so add method in the class linked list, we have defined add method to add the node. We to print the elements, we defined show method. To insert the node, we defined insert method. And to delete the node, to remove the node, we defined remove method. Like that, to modify the node, to modify the element, okay, we are defining modify method here. I am arranging the code, just a minute. I am arranging the code. Please wait. Okay. Yes. Okay. Now observe. So what are the linked list elements? Observe. I'm running the program. Linked list elements are, what are the linked list elements? Observe here. So linked list elements are 10, 20, 30, 40, 50. Okay. What are the linked list elements? 10, 20, 30, 40, 50. I want to modify this first element with 100. I don't want 10. I want to modify 10 with 100. So for that, I'm calling modify method. L1 dot modify. Give the position value as 1. I am giving new value as 100. Now press F11. Sorry. We have to print. Okay. After modifying, again I want to print the linked list elements. So call show method. Press F11. Observe. The first element modified with which value? 100. So if position value is 1, first x value is becoming v value. So now v value is 100. So first x value, first element value became 100 here. So we are modifying the first element. First element is not 10 now. First element is 100. We modified. Okay. Now I'm giving position value as 5. I'm giving position value as 5. Last node we are modifying. Okay. I'm giving position value as 5. Observe. Okay. Now fifth node value is what? 100. Observe here. Now fifth element is not 50. So before modifying element was 50. Now element modified. After modifying fifth element is 100 now. So we are giving position value as 5 means. So position minus 1 times that is executing. So first time this is pointer, next 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 time this is pointer. So pointer next is becoming for 1 time, pointer next is becoming pointer for second time, pointer next is becoming pointer for third time, pointer next is becoming pointer for fourth time. So position value we have given 5 means up to 4 that is coming. So pointer x value that is making as the v value. Now v value is 100. So 50 value replaced with 100. Pointer x value is 50 now. So that 50 value replaced with the v value. V value is 100. So pointer x equals to v means that 50 value replaced with the 100. So this is the code. We are modifying the last node. Now I'm giving position as 4. I'm giving position as 4. Observe. I'm giving position as 4. I'm pressing F11. See here. So fourth node modified as 100. Fourth node element modified as 100. Okay. So here just we are modifying the element. So we have no need to take 3 cases here. Just simply take 2 cases. Whether it is first element, modify like this. If that is not first element, modify like this. That's it. Okay. So this is about modifying an element in the linear single linked list. I hope you understood. Okay. So did you understand about modifying an element in the linear linked list? Please all of you give the response. Please all of you give the response. Did you understand about modifying element in the linear single linked list? Give the response in chat box. Okay. Okay, now I'm stopping the session here.